Assalamu alaikum. Bismillahirrahmanirrahim. This is a Juniper certification program, JNCIS-SP, that is Service Provider Routing and Switching Specialist. Today we discuss switching module, and chapter will be troubleshooting and monitoring. Okay, so let's start. Troubleshooting and monitoring have six sections. First, we discuss basic troubleshooting procedure and tools, and last we discuss regarding lab. Okay, common troubleshooting concept. Part one, like say situation one, you have recently completed work on the ISP network at your workplace for over a week. There have been no reported issues until today. When the phone rings, the manager demands swift action because the network is now broken. So you were just an administrator in any organization. It can be internet service provider or enterprise network. You have done some setup, and after some days, it may be linked down, or it may be a device malfunctioning. Okay, it's or it can be new requirement. So you have to work, you have to troubleshoot and fix. So this very basic troubleshooting steps. Number one is gather information. First, you need information. Okay, and then create an action plan, and last one is test possible solutions. Just I talk just to, take one example. Customer just sending a problem is um, we're getting packet loss for a specific destination. So in that case you got, or you have information. You have information. So most of the time, customer provide you the related information, and some information you need to gather, or you need to call it. So um, go for second plan, or go for second step. That means action plan. And number three, just in case what will be the possible solution, and check one by one. So this is the very basic step. So understanding your environment, know what is normal for your environment. So before troubleshooting, you have to know your network better. Otherwise, you can't do troubleshooting, or you can't resolve your problem. Okay. Okay, so number one, establish baseline before a problem occurs. Environmental conditions, resource utilization, traffic types, and loads. It's all about device local resource. Okay, device local resource and environmental conditions. Many tools are available. Just you consider um, you want to view some data like interface statistics, like device resource utilization. Okay, so if you collect those one, then you can easily collect related information for troubleshooting. Okay, so this is um, or you can use like NetFlow. That is NetFlow, and NetFlow is similar tools. Be sure that the baseline is representative, records regular monitoring over time. So you have to maintain monitoring system like Cacti or LPAM. Uh, Lots of monitoring tools is available. So you have to set up one or two monitoring tools for better understanding. Okay. First, gather information. Does a problem really exist? What is symptom and how does it relate to a problem? Which resource can help me gather relevant information? So you need some mm, like you need some system to collect information. Okay. So next, layered approach and go. Also, uh, ah, okay, 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 okay. Ah, okay. If you consider layer approach, you know about OSI layer, that is layer 1 to layer 7, that is application layer to physical layer. Most of the time, we analyze our problem based on OSI layer. Okay, so if you are getting a link down, so no need to troubleshoot further layer. Link down, that means that's a physical layer problem. You can you can make a solution for this problem. If link restored, that will be okay automatically. Okay. If yeah, if you have redundant link, just consider your primary link goes down, but traffic not goes through secondary link or failover link. In that case, you have to troubleshoot. What's the problem? It can be high power in fiber optic, or it can be port problem or SFP problem like this. Okay. So layered approach may help us very much to troubleshoot our daily or regular problem. Okay. So hardware troubleshooting flowchart is it's a completely hardware related problem like display and view alarms. And you can get alarms from for LED indication, or you can get alarms from different CLI command. If it's come from chassis, you can get or you can collect those alarm from or log from chassis alarms, and you can also collect all log from syslog. Okay. So this is the hardware troubleshooting procedure like alarm safety, LED indication component failure, hardware related log entries, FPC, PIC port operational, and investigate software faults. So it's total about hardware troubleshooting process. If your hardware is falling down, then you can check this flow chart as per flow chart. Okay. Each hardware okay. If you think your hardware is okay, then you can check your software process or your software. If your software is okay, then you can collect some um, record from interface statistics and some local resource utilization record for further troubleshooting. Okay, so this is the question and answer section. So arrange the steps of a basic troubleshooting approach in the correct order. So what is the first step? Gathering information. Second step of creating an action plan. And third step is testing possible solutions. This is the question number two. Why should you gather as much information as possible before attempting to fix the problem? First one is to get answer to key question relevant to the situation, and second one is to identify the problem. If you if you have not collected enough information, basically you are not able to fix the problem. Okay. Common troubleshooting concept. There is part two, using system logging and trace options. Every protocol have debugging sections in Juniper. Okay, so if you understand, it's a specific protocol problem. It can be RSVP or it can be a different routing protocol. If you identify it's a routing protocol problem, then you can just enable trace option under the routing protocol and analyze the log. What's the problem? Okay, every log information you can call it from syslog. So you can get this syslog message from syslog server also, or you can also try get log from live log from your device, router or system. Okay, another very important command which provide you local resource utilization and router uptime. Okay, shows the access routing engine. This provide CPU temperature, RAM utilization, CPU utilization, uptime. So this is very important command to checking is the problem in hardware or is the problem in environmental like temperature like this. Okay. Show system code dumps. So this command basically show you any software fail happened. This command help you to find out the is there any issue in software. Okay, creating an action plan. So this is the second step. Second step, when creating an action plan, you should list possible causes that match the symptoms, such as common issues typically fall into one of three categories. That it can be physical, it can be software, and it can be configuration. Okay, so first, troubleshoot physical. If physical is okay, then go to software. It can be bugs of software. If you think your software is okay, then go to your go to and check your configuration. Check your configuration. If any misconfiguration happened, then fix the configuration. So it's a action plan. Multiple tests. You have to make multiple tests to get a solution of a different problem. Okay. Working with JETA, critical and non-critical issues. If you not solve your problems through just you check the physical physical is everything is okay, you are just check software also, so you think your software is also okay, and check the configuration, you think the configuration also okay, but your problem not solved yet, then you can communicate with Juniper and they will give you the solution. Okay, this process is called JTAG. Working with JTAG standard output commands, just share the standard output commands with mail, or you can connect with them and take real-time troubleshooting. Okay. Again, we're now question answer section. Question number one, what are the categories that common network issues fall into? Physical, software, and configuration is the measure. Okay, what is executed in the final step of a basic troubleshooting process? The purpose test. Troubleshooting tools. Lots of tools is available here. Okay. Number one is monitoring CLI outputs. So you can place a CLI command for uh, verification of your command output. If you are getting um, expected result, uh, that will be no problem. But you don't get any expected result, that will be a problem. Okay, so monitoring CLI output will help you to troubleshoot most of the problem. And number two is sampling and analysis research and utilities. That means you just forward your traffic in external server that can be NetFlow or JFlow or IPPX server. You are just collecting data and uh, mm, external NetFlow server show you visible information. Okay, then you can take decision. You can take some information to mm, uh, to take an action. Okay, system logging and reception that will help you. System logging and reception, every protocol have reception or debugging options that will help you also. SNMP and third-party monitoring tools. SNMP and third-party monitoring tools also help you to identify the problem. And then finally you after multiple tests you can decide what will be the solution. Okay, SNMP. I know, we know SNMP better, Simple Network Management Protocol. It's an UDP protocol, and it's an external server. They are collecting data from your device and show you different item information like interface, local resource, BGP information, or protocol information. Okay, set health monitor. So this the increased traffic, original traffic packet data sample to JFlow collector. JFlow collector show you which traffic is passing in ingress interface or outgoing interface, and you can analyze your traffic. Okay, so an overview of JFlow keeps track of sample packets. Record of sample packets are aggregated or reported. JFlow collector situated outside the Juniper device as a separate appliance. Support for JFlow version 5 and JFlow version 8. Um, Also, you can introduce JFlow version 9. So there is some restriction here. Sampling by routing engine require no additional hardware. Dedicated MS DPC or an MS PIC allocates a separate services plan that eliminates any performance implications. So JFlow version 9 introduces a new template. Inline JFlow version 10 provides increased sampling capacity with limited for forwarding impact. Reports are sent to JFlow connector. So multiple options you have version 5, 8, 9, and new is version 10. So you can use with version support for your device. Okay. Uh, Beside JFlow version 5, JFlow, you can use IPFix, NetFlow, or SFlow. Okay. So multiple options. You have multiple options for check. There is IPFix. IP flow information export protocol, that is IPFix. Set template type IPv4, IPv6, and this is the sample configuration of IPFix. Configuring inline JFlow, it's a template configuration of inline JFlow. Okay. Configuring inline JFlow, just sampling, just set your server, external server, and the port number, and version IPFix template, and inline JFlow source address. Which source address deliver this metadata to um, external flow server. Okay, and configuring inline JFlow chassis configuration. It is chassis. Chassis bind the JFlow sampling instance to the MX3D trio APC. Change the flow table size. You can change your flow table size. For MX80 routers, you must bind the trio forward engine base to a sampling instance. So different model support. Yes, it's like NetFlow. It's like NetFlow. NetFlow in Cisco, there is NetFlow and port mirroring is available, but in Juniper, there is multiple options. Same task, same task. You have multiple options. You have IPPX. You have um, that means S-flow, Z-flow. Okay, multiple options. We have multiple options for testing. Similar with NetFlow. Okay, configuring inline JFlow firewall filter configuration. If your device is firewall, then it's configuration sample. So this is another question and answer section. Which option does SNMP use to gather system information? Get request. From get request, they're getting the information from your device. Okay. Which command display information about packet that are sampled by inline JFlow? Show services accounting flow, inline JFlow. And another tools for troubleshooting is port mirroring. Port mirroring. Port mirroring, that means you are just copy traffic from one interface and sending to another interface to your external server. The external server collecting the data and they collecting the data and analyze through external software. It can be TCP dump or it can be Wireshark. Okay. So it's the packet analyzer is connected with your device. You are sending one interface traffic to your packet analyzer. Then packet analyzer just analyzing the traffic. Is there a normal traffic or is the abnormal traffic? Okay. So this is the sample configuration. Edit forwarding option, port mirroring, input, write one, family inet, output. This is the output. Configuring port mirroring firewall filter, firewall family inet, filter port mirror, tram1, then port mirror is the sample configuration. Is it possible to emulate port mirroring in EVNG? Yes, yeah, it's possible. Um, your it's a virtual device. Okay, after finishing our theoretical section, we'll go. Okay, then show you the sample. Okay. Static ERP for IPv4 port mirroring. This is you can set static ERP. That means you are setting IP address and MAC address if you want. Not necessary. It's an optional. Okay. Inline port mirroring. Inline port mirroring provides multiple port mirroring instances per chassis, and they have three options. Asset by decoupling the port mirroring destination from input parameters. Port mirroring child instance can inherit input parameters from a port mirroring parent instance. And inline port mirroring is only available on MX3D trio-based line cards. So that have some limitations. Okay, but port mirroring is very simple. Just you copy one interface or multiple interface traffic to a specific destination interface. Okay, and for and analyzer just analyze your sending traffic. Okay, configuring port mirroring instances. This multiple options. Forwarding options, port mirroring instance. First option is parent one. They are calling the parent one, and next is parent child one. Child one also under parent one. Inline port mirroring chassis and firewall filters is the another example. Chassis APC0 port mirror instance parent one. Another example. And this is the port mirror verification. Show forwarding options port mirroring. And this is the question answer section of port mirroring. What is the first step while configuring port mirroring? Navigate edit forwarding options port mirroring. We'll get port mirroring configuration. Yeah. Voice command is issued to verify the state operation of port mirroring instance. Show forwarding options port mirror. So now our case study network congestion. This is the sample topology, DS1 and DS2, and that means distribution switch 1, distribution 2, and two switches is access level. And this the show is spanning tree interface. This basically layer 2 topology, and MST is running here. Multiple spanning tree is running here, and testing possible solution, change VLAN membership for MST1 to 10 to 19. This is sample configuration, show protocols, MST configuration name, my MST config. This is this device configuration, MSTI1, bridge priority 8K, VLAN 10 to 19. MSTI2, instance 1, this is instance 2, priority is 16K, and VLAN is 20 to 29. So this is the problem. Topology symptoms and relevant information. User connected to access switch 1 and access switch 2 are complaining about congestion and latency issues. Access switch 1, access switch 2. They are complaining, they are getting problem, they are getting congestion. Okay. And packet loss and latency issue. You have recently implemented multiple spanning tree protocol to load shared traffic between DS1 and DS2. User complaints continue. That means it can be all traffic, access 1 and access 2, all traffic is coming to destination 1. In that case, they're getting congestion in link. So what will be the solution? Access 1, show spanning tree interface. This is instance 0, this is instance 1, and this is instance 2. See here, the VLAN is 0123, 0123. So instance 0, this is instance 1, 8 and 10, two interface, 8 and 10. Instance, for instance 2, there is two interface also, 8 and 10. Just a minute. Go to our case study section. Okay. So see, this is our topology. The problem is who are connected with access 1 and access 2, they are getting congestion and latency issues. Okay, so this is the problem. So need to resolve this problem. So go to first see here, they are just taking some CLI command output, CLI command output in access switch 1. There are multiple instance 0, instance 1, and instance 2. All instance, the interface is 8 and 10, 8 and 10, 8 and 10. Similar. Which device is selected as the root page for its multiple spanning tree instance MST group? This is a major identification. So say here designated port, root port, designated port, root port, designated port, root port. So a designated port ID, designated brace ID. This is the designated brace ID. This is the designated brace ID. For instance 0, this is the designated brace ID. For instance 1, for instance 2. Show is spanning to MSTP configuration. So MSTP configuration, there is a name is MSTP config, and instance 1 member VLAN is 0 to 9 30 to 4094. Instance 1 VLAN ID is 10 to 19, and instance 2 VLAN ID is 20 to 29. Your this accessories 1, the port is 0 to 23, 0 to 23. So this is the VLAN range. For instance, show is spanning to MST configuration from this output from access switch 1, this output from distribution switch 1. Distribution switch 1, there is MST 0. The VLAN range is here 0 to 9, but here is 0 to 10, and 30 to 4094. This is okay. For instance 1, VLAN ID is 11 19 10 19. Instance 2 20 29. So something different in instance 1. Compare MSTP configuration on access switch 1 and distribution switch 1. There is some um, difference in MST1. Okay, then next, testing possible solutions. Change VLAN membership for MST1 1 to 10 through 19. This is the problem in basically distribution switch 1 and MST configuration. MST1 base priority 8K and VLAN ID will be 10 to 19. So this is the configuration mismatch. Configuration mismatch. So you have to troubleshoot those. Okay, let's find now question and answer section of case study, neural transition. Question 1. What happens to end user traffic when two routers and DS1 and DS2 function as root bridge in this network? Traffic is distributed between the paths and congestion subsidies. You can you can load balance traffic through MST to creating multiple spanning tree under MSTP, multiple spanning tree protocol. Okay, some VLAN range will be in one instance, and some other VLAN will be in another instance. So for some VLAN, distribution 1 will be the primary, and the other VLAN distribution 2 will be the primary. So you can load balance traffic. Okay, so what information does the configuration digest contain? Resume name, revision label, and MSTI to VLAN ID mappings. These three information should be correct. Troubleshooting and monitoring. This is the end of this session. So we can test some configuration syntax in our lab. Okay. So first checking net flow or JFlow. How to configure net flow or JFlow. Um, this is SNMP. SNMP configuration is very much easy. So going to flow. Yes. Configuring inline JFlow. Um, packet. Yes. Getting. Yes. What is JFlow? Are I getting the sample configuration? So how to configure JFlow? This is the configuring inline JFlow template. So this is a sample configuration. This configuration is under services, edit services, flow monitoring, then version, then template. Just checking or EVNG supporting this one or not. Yes. appearance. Okay. But real device obviously support this configuration, and also have some software version limitation or hardware line cut. Device user is root, password is root 123. Select edit. So edit services. Now I'm in under services. So set what is available is flow monitoring. Flow monitoring. Flow monitoring. Yes, flow monitoring is available here. Flow monitoring. Then flow monitoring. The available option is version 9 configuration, and another option is version IP fix. Flow monitoring version IP fix. So you can set version IP fix, then go for template. Template, then template name. Set the template name. Test template. Test template, and you can say it for IPv4 or you can say it for IPv6. So I said here IPv4 or IPv4. So this is the sample configuration. It's like this IPv4. And commit check. Is this configuration is okay? Yes, okay. Supporting this one. Use IPv6 template for IPv6 traffic. If you want capture IPv6, then mention IPv6 like this. Like this. Temp v6. Temp v6. And flow set flow monitoring version IPv6 template v6 and set here IPv6. So IPv4 template and this one is IPv6 template. Now check. Yes, configuration is okay for IPv4 and IPv6. So this is the configuration of IPv6. How to configure the template. Then configuring inline JFlow input parameters, edit forwarding options, sampling, show instance one, input rate. You can set run length and maximum packets per second. Per second, how much packet you will take. So edit forwarding options, sampling. So edit forwarding options, sampling. Yes, under edit forwarding options, sampling, set input rate, traffic sampling data acquisition, input rate, input rate, you can set this range 1 to 65,535. So I set here 100. Next, run length, number of samples after initial trigger. You can set here, and the range is 0 to 20. I set here 10 and max packets per second. Max packets per second. You set here, like I said here, 3, 4. Set here, yeah, 10. So setting done. It's basically depends on your interface traffic. If you are collecting interface traffic is used per second packet will be more than this. So you can modify this. Okay, just I'm showing you an example. Okay. Okay, then IPFix template done, sampling done. Next, forwarding options, sampling, family inet output. Then mention the server address, external server address. Okay, external server address. After mentioning this one, set family inet for IPv4, and you want to send data to external server. Your flow server, your flow server, set your flow server IP here. Like I said, example 10.10.10.100 as like example on our slide, and port number is basically port number getting from external server, and the port example port is 2055, and version IPFix. Version IPFix is available here. Version IPFix is available. Flow server, then flow server, then version IPFix is not available here. Port. No, it's not available here. So this not basically supporting this. Then and the version set, you can set the version 5, version 8, and this is different. So IPFix not IPFix sampling not support in virtual VMX, but physical device will support this one. Okay, but version 9 will support here. Version 9 will support here. Okay, so version IPFix template, and you call the template reference template. Okay, and inline JFlow, and you I need to set the source address, that means router address, who is um, device address sending traffic to your external server. So this is another example of inline JFlow configuration, chassis, under chassis. Okay. Totally not supporting virtual device, our VMX, not supporting all things. There are some limitations. Okay. So you can test your real device. It's our device limitation. Sorry for that. Show, check. Up to the configuration is okay, but they're not taking enter configuration of IPFix. But it's support version 9, version 5, or version 8, or version 9. So this is basically template configuration in your slide. You can test this configuration sample in your production real hardware. Okay, Alvarez, I think you got my point. Hello.
Yes.
Okay, so today I want to close now. See you in next class. That will be our new session. That will be our new session. Our new session will be MPLS. Our switching section has finished. So our next section would be number 3, Open Learning, Junos MPLS Fundamentals. So welcome to our new session. Thank you for joining today. Bye bye.